The last lesson in this unit is taking a look at interpreting graphs of functions. So part of what we need to do is be able to take a look at a graph and then based on the context of the question, be able to justify what is taking place in the graph. So for the first example, the Carter family are driving to Yukon for a family vacation. The graph represents the amount of fuel in liters in their gas tank of their car on the first day of their journey. We can see that we have A to B is decreasing, B to C is staying the same, C to D is going back up, and then D to E is decreasing, E to F is the same, F to G is decreasing, G to H is going up, and H to I is going to be decreasing again. We can also see that we're looking at the left-hand side is going to be the amount of fuel, and that the domain is representing each tick is 1 hour throughout the day. So, with reference to the journey, what is happening between A and B? Well, logically speaking, A and B is the fuel is decreasing over time because they are driving towards destination. Between B and C, the amount of fuel stays the same because they're stopped. And between C and D, the amount of fuel increases because they are refueling or gassing up. Now, when it says what is the rate of consumption in liters per hour, I'm looking at the change in the amount of liters divided by the change in hours. So because I'm looking at this section here, I'm going to follow my graph and say, well, how many liters did I start with? I started with 60. How many liters did I end off with? I ended off with 25, which means that I'm going to subtract 25 and say that the difference is going to be I used 35 liters. I'm going to divide that by what my change in time was. Well, at this time, it's going to be 10:30. And at this time, using the 24-hour clock, it's going to be 14 o'clock. Which means that if I take that 14 minus 10.5, or halfway past 10, then it has spanned 3.5 hours. When I divide 35 liters by 3.5 hours, then my actual fuel consumption is going to be 10 liters per hour. Which line segment represents the car being refueled for the second time? Well, I'm just looking at when is it increasing again, and we can see here the second increase happens from G to H. If I'm calculating the total time the car is being driven, then I'm going to add up all the times that the car has gas decreasing. So one of them we've already taken a look at. We said that the car's gas was decreasing from D to E. It's also decreasing from A to B, from F to G, and from H to I. Now, for these ones, I can see that it passes 1 tick, so those are each going to be 1 hour. I already solved for D to E when I was solving what the rate was. We had 3.5 hours pass. And going from A to B, I had 1, 2, 3 ticks, so that's going to be 3 hours. So if I'm looking at what the total time driven is, I'm going to say that I'm just adding up the changes that are happening. I have 3 hours plus 3.5 hours plus 1 hour plus 1 hour. The total time driven is 8.5 hours in this first day. If fuel costs 85 cents per liter, calculate the cost of the fuel used for the first day, which means that in this case, I'm looking at what the decrease is, but I'm not looking at it in terms of what the time is. I'm looking at the changes on these same 4 sections in terms of how much fuel went down. Well, from here I went from 50 down to 20, so I used 30 liters. Here I went from 60 down to 25. This one we already solved as well. We used 35 liters. Here I went from 25 down to 15. I used 10 liters. And the same thing up here. From 60 to 50, I used 10 liters. So I'm going to take the 30, 35, 10, and 10. And say that the total amount that I used was 85 liters. If that's the amount of fuel that I used, then the cost of the fuel is going to be the amount of fuel I used multiplied by the cost of the fuel. If it's 85 cents, it's going to be $0.85, which means that the fuel for the first day cost me $72.25. Let's take a look at example 2. Suggest a possible scenario for each of the following graphs. Well, there's literally infinite possible scenarios. So if you're looking at like speed versus time graph where the speed is constant, then it slows down, then it's constant, then it speeds up, then it's constant, then it slows down, you could say that what's happening is cars driving, it slows down for a school zone, speeds up again, and then slows to a stop. For the second graph, I'm going to say that if it's speeding up to its top speed and then instantly starts slowing down, then speeding up to its top speed and slowing down, I could just say that this is a pendulum. Swinging back and forth. Remembering that there's literally infinite possibilities, And as long as you can justify your answer, that's good enough. Typically, if I'm going to quiz you on something like this, I will give you 4 possibilities and you need to pick which one makes sense. All right, and if we are sketching out a graph, if I am sketching a graph of the oven temperature when baking a pie, well, if I'm looking at the oven temperature when baking a pie, it's not going to start at 0 degrees because that's freezing. So I'd say it starts a little bit above that. It's going to heat up to the pie baking temperature. Then it's going to stay the same while I'm cooking the pie. And then when I am done cooking the pie, I'm going to turn the oven off, and it's going to slowly start to decrease in temperature again. If Ben is taking part in a 100-meter sprint, he is going to quite quickly take off and speed up, and then he's going to hit his max speed, and he's going to sustain that until he hits the flag, and then he's going to slow down again. All right, hopefully that makes sense. You can go ahead and try some of that practice.